So now we're going to talk about the rules for simplifying radicals. When I say simplify, what I mean is I want you to remove all perfect roots from the radical leaving anything not broken down inside the radical. And that's a little ambiguous until we start actually just simplifying. So let's just jump in and play with those rules. I'm going to ungroup these. Let's do that. Okay. So to check to see if something can simplify, I want to see if I can find any perfect indices in here, so perfect roots. In this case, since my index is a 2, I am going to look for perfect squares inside the 18. And at this point, 18 isn't a perfect square. I know that. So what I will employ is a factor tree. You don't necessarily need one for this, but I know that my 18 is a 2 times 9, and that 9 is a perfect square. So I am going to rewrite this 18 as the square root of 2 times 9, which I can take the square root of 9, so the square root of 2 times the square root of 9, break it apart. And that square root of 9 is a 3, so I've got a square root of 2 times a 3. And then convention has us write the square root last, because this could be ambiguous. Is the 3 under the radical with a 2 or not? Sometimes it's hard to see, so we like to write the radical last, and that would be our final answer for that problem. I'm going to try to do the same thing for the square root of 14. I don't know why these grouped. Here we go. Ugh. Okay, clearly they're not separating from each other, that's alright. I can manage that. So the square root of 14 is... This would look like maybe the square root of 2 times 7. But neither one of those break down anymore. None of these are perfect squares, so actually our final answer would be the square root of 14. It doesn't break down anymore. It doesn't simplify. So then on something like the cube root of 40, for instance. Let's try this one next. Maybe you see a perfect cube inside of 40, maybe you don't. So again, we'll go to our lovely factor tree. And inside of 40, I see a 5 and an 8. You could have seen a 4 and a 10, you could have seen a 2 and a 20, it doesn't really matter. That 5's prime. And 8, you may or may not know, is 2 cubed. So how we see that is breaking it all the way down, and there are 3 2's there. So I could write this as the cube root of 5 times 2 cubed. So it's the cube root of 5 times the cube root of 2 cubed. And those 3's on the 2 will actually cancel each other out. That radical and that index cancel each other out. So I'm left with, I'm going to move the 2 to the front, and the cube root of 5. And that would be the answer for that problem. So I've got one more to look at on this slide. and that will be the fourth root of 162. I don't really have a good place to do that, so we'll block him off, and we'll block him off, and then we'll work over here. Try to be organized in your homework if at all possible. I can't figure out a good way to organize these slides yet, so I apologize. Again, I don't know off the top of my head what the fourth root of 162 is. I don't even know off the top of my head if there are any perfect fourths inside of that. So I'm going to again use a factor tree. And I'm going to break that. I know there's a 2 in there. And if I use my calculator, I find out that 2 goes into 62 81 times. And 81 is 9 times 9. And 9 times 9, I've got 3 times 3 and 3 times 3. So when I look at the fourth root of 164, it's really the fourth root of 3 to the fourth here times my lonely 2. And so when I break up my radical, fourth root of 3 to the fourth times the fourth root of 2. This fourth root of 3 to the fourth simplifies to a 3. And then I keep my fourth root of 2. And that right there would be my end result, my simplified answer. I'd like to try one more. So let's move on and try one more problem. I think I have many on this slide. We will just, I want to hit about the 10-minute mark on the recording, so I will do as many on here as take me to 10 minutes, and then we'll start a new video. So let's start with the square root of 81y to the 5th. I would like to break this down into the square root of 81 and the square root of y to the 5th. So we will write it out that way. This is the square root of 81 times the square root of y to the 5th. You may know the square root of 81 at this point. I'm sure many of you do. That one can just be 9. But the square root of y to the 5th, I would like to break this down into pieces. So y to the 5th, you could think of it as y, 5 of them. And since my index is 2, I'm looking for groups of 2 y's. So here's a group of 2 y's and here's a group of 2 y's. So really how I'd like to write this is my 9's here, and I've got the square root of y squared and y squared and y. So then I can take my square roots of y squared and simplify them one at a time. So I have a 9 times a y times a y and times the square root of y. And now I can simplify. 9y is 9y squared, and then I keep the square root of, not 2, call that a y. Another way you could visualize this, let me just remove these really quick. Another way you could visualize this, and it might be helpful for some of you, we could also do this using rational exponents. So, again, I'm just going to rewrite my problem. 181y to the 5th. First step would be the same. Break it into your square root of 81 times the square root of y to the 5th. And you can even still just turn this into a 9 if you'd like. but I would like to write this y to the 5th as my rational exponent. So this is y to the 5/2 power. So when I look at my 5/2 power, if I look at this, if I think of this like a mixed number, 2 goes into 5 2 times with 1 left over. So I can say that I have 9 times y to the, let me see if I can get this box to go away. My 9y to the 2 1/2 power. And if I think about it, I could write that as 9 times y squared. There's my 2. Actually, let's move this over a little bit. This y got really long. I don't know why. Haha, I don't know why. I could write this as 9y to the 2 plus 1/2. There we go. That could be the exponent on y, which is really 9y squared times y to the 1/2. If I make use of my rules of exponents, this turns into this. So that leaves me with 9y squared, and y to the 1/2 power could be written as the square root of y. And you'll notice that I get the same place whichever method I choose to do this. I just have to be careful as I'm thinking through my exponents. So that's the end of this video. We will come back and do a few more of these in the next video.